Right, let's have a look at the intro for solving simultaneous equations. I've done a couple of simple examples just to illustrate the method that we're going to use in this section then. So what are we going to do? Right, okay. So this equation here then, these ones here, 3x plus 4y is 5, 4x plus 2y is 6. How would you solve these? Well, basically the way to do that, they're all arranged in the correct positions, x's, y's and numbers. We look to get the same number of x's in both or the same number of y's and subtract them from one another if they are of the same sign. So here, for example, we could do 4 of these would make 12 and 3 of those and take them away from each other. So we could do 4 lots of 1, take away 3 lots of 2. Do you see that? That would be 12 and 12 and they would cancel each other out. And then you get 4 of those, which is 16. Take 3 of those, which is 6. 16 takes 6y is 10y. That will give 10y. 4 of those is 20. Take 3 of those is 18 is 2. And then you'd be able to solve for y. Once you know y, you can just sub it back into either one of these, 1 or 2, and get x. So that's essentially the method. So we could have done it that way. And I know I'm cutting a long story short here. The examples go into it in a bit more detail, of course. So 4 of these, take 3 of those. Now what else could we do here? Well, there's a slightly simpler route, isn't there? If you look at the 4 and the 2, for example, you'd just need 1 of these, take 2 of those, wouldn't you? So why don't we do that? 1 of these, take 2 of those. If we did that, so equation 1, take 2 lots of equation 2 then. 1 of these, take 2 of those. Now that's the problem here. If I did it that way round, I'd end up with a minus so many x's. It would be that 3 take 8 would be minus 5x, which isn't nice. So you wouldn't really want to do that. Even though you want to do this approach here, you'd do it the other way around. So let me do it the other way around then. So you do, because this is bigger than that, 2 of these, take 1 of those, will give a positive x. So 2 lots of 2, take away equation 1 then. 2 of these, 8, take 3 is 5. 2 of these is 4, take 4 is nothing. 4y, take 4y is nothing. So the y's disappear, that's why we're doing it. 2 of these is 12, take away 5 is 7. 5x equals 7. You can solve for x and then sub back into one of these, either this one or that one, whichever's easier, and you can get y. So that's the way around with that sort of arrangement. Now if we looked at the other arrangements that we can have, typical example is here, when they have one of these components have opposite sides. This is quite nice because then you can just add them, which is easy to do. So if we did 4 of these, we'd get minus 20. 5 of those, we'd get plus 20. And if we added them together, they cancel each other out. So if we do 4 of equation 1 plus 5 of equation 2. So let's do 4 of equation 1, 4 of those, plus 5 of equation 2, and it should work out fine. 4 of these is 8, 5 of these is 15, 8 and 15 is 23 lots of x. 4 of these is minus 20, 5 of those is plus 20. They'll cancel, give nothing here, so we don't need to write it down. 4 of these is 28, so let's just write that out because it might be difficult. 5 eighths are 40, 28 and 40 is 68, so you get 23x equals to 68, and then we can just move the 23 from times to divide and work out x. And then once you know x, you can sub it in, and in practice here, you'd probably want to sub it in this one. This one looks easier, and you would simply write 2x equals, you'd say by 1, 2x equals, and then you'd write down 7 plus the 5y. You'd move that over in your mind's eye and write it down, and then put, oh, we're solving for y, aren't we, not x, because we've got x. So I would write it the other way. I'd probably use this one then. So let me scratch that because I've illustrated it not well there with the wrong one. So by 2 is what we'd use, wouldn't we, of course, looking at the problem. We know x then. So we want to find y, so that looks easier to use. Or we could use this one still, but no, this one would be the one to use, wouldn't it? 4y is equal to 8 minus 3x is what we would write down. We know x, we put it in, and then we could solve for y, no problem. So I hope I've just said a few little snippets of things that I generally try to do in the method of solutions that I employ to solve simultaneous equations. And this is the characteristic type of things. If they're the same side, sign, we look for the easiest combination and take multiples away from each other to make one of the components, the x or y, disappear. If they're opposite signs, then we can simply add so many of these and so many of these together, so that in this instance the y's disappear. If the x's are opposite signs, then we would do the corresponding method for the x's. Okay then, so all the best with this section. Hope you get on okay with it, and I'll catch you again. Cheers!